Let's look at example 6. A specialty shop owner used a revenue function and a cost volume function to analyze his monthly sales. One month he found that with a sales volume of 1,465 items, okay, so he sold 1,465 items, he had a revenue of $32,962.50 and total cost of $26,405.50. Another month, he had a total cost of $17,638 on sales of 940 items. Find the linear revenue function, the linear cost function, and the break-even point. Well, the linear revenue function, remember linear revenue functions, they look like R of X is equal to the selling price, right? Isn't that typically the price times the number of items? So in this case, we know that one month they sold 1,465 items and generated $32,962.50 in revenue. So can't we simply divide the $32,962.50 by 1,465 to figure out what the individual selling price per item was? And if we do that, if we take that 32,962.5 and divide that by 1,465, we get a figure of 22.5. So the price was equal to 22.5, or what, $22.50 was the selling price of our items? So that allows us to write the revenue function 22.5x, where x is the number of items that we are selling. So, again, we simply took the total revenue divided by the number of items that we sold. That gave us a price per item. Now, we need to find the cost function. Well, we know two different situations where a number of items produced a certain cost. Can't we use those as points and find the slope using those 2 points for our linear cost? So we would take the difference of y, which is the cost, divided by the difference of x, which is the number of items. Because remember, our cost function is going to look like c of x equals mx plus b, where m is the slope. It's the cost per item. C, the y, is the cost. X is the number of items. So slope is change of y over change of x. That's cost per item. So if we take that difference in the costs divided by the difference in the items, that ends up giving us a figure of 16.7 for our slope. Because when we take the 26,405.5, subtract the 17,638, that gives us an 8767.5. That's the change of cost, that's the change of y, over the change of x. So that's 1,465 minus the 940. That's a 525. And when we do that division, when we take 8767.5 and divide it by 225, we get 38.9666, so approximately what, 30? That's not what I got before. I think I made some mistake in my calculations here. 8767.5 divided by 525. That's looking a little better. Gives us a value of 16.7. I guess I can't punch the buttons on my calculator very well. That's why I always like to do things ahead of time. So our M value is 16.7, which actually says what? $16.70 is what it costs us to make each item, plus our fixed costs. And the way we would find our fixed costs is pick one of these cost figures, put it in for C of X, take the corresponding number of items, put it in for X. That would create the equation that we could solve for B. If we did that with the first set of values, that give us 26,405.50 equals 16.7 times 1465. And if we then solve that equation for B, we should find that B equals 1940. So that's $1,940 as our fixed costs. And we now have our revenue function, we have our cost function, and we can find the break-even point. Break-even is where revenue, you've sold enough of your items so that the revenue from selling that number of items covers the cost for making that number of items. So 22.5x has to cover 16.7x plus 1940. And when we solve that linear equation in one variable, we get x equals roughly 335. So it's going to take us 335 items to make and sell in order to break even. So in this situation, to find the break-even point, we first of all had to construct our revenue and cost functions. Then we could go through the break-even analysis to answer the question.